primary database went down at 3:12 a.m. The failover script never ran site down for 14 minutes. The webhook endpoint had an expired self-signed certificate. Let's break down Event-Driven Ansible, how it works, and the exact mistake behind that failure. Event-Driven Ansible, or EDA, is a framework that lets you define rules that listen for events, like a service going down or a file changing, and automatically run Ansible playbooks. You set up an event source, write a rulebook that maps events to actions, and the engine handles the rest. Polling with cron jobs is wasteful. They run every few minutes regardless of whether anything needs to happen. Event-Driven Ansible flips the model. It listens for events and reacts instantly. No more wasted cycles checking for problems that don't exist. Here's a side-by-side comparison. The polling approach uses a cron job to run a playbook every 5 minutes. The event-driven approach uses a rulebook that listens for a specific event, like a service failure, and reacts immediately. The most common production setup is a webhook endpoint that receives post requests from your monitoring system. Here's how to configure a simple webhook source that listens for JSON payloads on port 5000 and triggers a deployment playbook. This rulebook defines a webhook source that listens on port 5000. When a post request arrives with action, deploy, and environment production, it runs the deploy app, IML playbook, passing the version from the event payload. Rulebooks are the brain of the operation. They define the logic. When an event arrives, what condition must be true and what action to take. Conditions can check event fields, nested values, or even run Jinja2 expressions. Actions typically run a playbook, but can also run a module directly or send a notification. This rulebook has 2 rules. The first restarts a service when a critical high CPU alert fires. The second sends a debug message for warning alerts. Rulebooks are evaluated in order. The first matching rule wins. The EDA Controller is a long-running process that listens for events. In production, run it as a systemed service or in a container with restart policies. Never run it as a background job in a terminal. It will die when you log out. Use a dedicated user with minimal permissions. This creates a systemed service for the EDA Controller. It runs as user Ansible, restarts on failure, and logs to journaled. You can check the logs with journoctl to monitor its health. Events can arrive multiple times due to retries from monitoring. Your playbooks must be idempotent. Running them twice should have the same effect as running them once. For deduplication, track event IDs in a RIDI's cache and skip already processed events. This playbook checks if an event ID has been processed by looking for a marker file. If the file exists, it skips the restart. Otherwise, it restarts the service and creates the marker file. This ensures idempotency. For high throughput, run multiple EDA controllers behind a load balancer, each with the same rulebook. Use a shared event source like Kafka that partitions events by a key, such as hostname, to ensure related events go to the same controller. This avoids race conditions. This rulebook uses a Kafka event source. By specifying a partition, you can control which controller processes which events. Partitioning by hostname guarantees ordered processing per host. This is the same issue we highlighted at the start. Here's exactly why that happened. At 3:12 a.m., the primary database went down. The monitoring system tried to send a webhook to the EDA controller, but the webhook endpoint was configured with a self-signed certificate that had expired. The HTTP post failed silently, and event-driven Ansible never received the event. The failover script never ran. The webhook source used a self-signed certificate that expired, causing the failover script to never run. Switching to RabbitMQ with TLS eliminated the certificate management issue. The fix was to switch from a webhook to a message queue, RabbitMQ, with TLS. This ensures reliable delivery and provides health checks on the connection. Additionally, a dead letter queue was added for failed events with a retry mechanism. The event source now uses Ansible, EDA, RabbitMQ instead of the webhook. This gotcha is exactly the incident we saw. When using a webhook source, if you don't properly configure TLS certificates or monitor their expiry, the connection can fail silently. Always validate the event delivery path end-to-end, including certificate expiry and network timeouts. A common mistake is using hosts, all in EDA-triggered playbooks. This can cause the playbook to run on every host in your inventory, not just the one that triggered the event. Always scope actions to specific hosts using variables from the event payload. Never enable auto-remediation without first testing in dry run mode. Run new rulebooks with dry run for at least a week to validate behavior before enabling active remediation. The Ansible EDA, Alert Manager and Ansible EDA webhook source plugins shown require Ansible Rulebook from the Ansible Rulebook package, not Ansible core. Ensure you have Ansible Rulebook equals 100 installed. The Ansible EDA collection must be installed via Ansible Galaxy Collection install Ansible EDA. The article mentions dry run mode, but doesn't show how to enable it. Use the dry run flag with Ansible Rulebook to log actions without executing them. This is critical for validating rule logic before going live. The webhook source in the article listens on 0, 0, 0, 0, 5000 without authentication. In production, always secure the endpoint with a secret token or TLS client certificates. Use the token parameter in the webhook source or place it behind a reverse proxy like Nginx with authentication. When things go wrong, start with the controller logs using journoctl. Verify the event source is reachable with a curl post. Finally, check the rulebook syntax with the syntax check flag. Let's run through some common interview questions. How does EDA handle duplicate events? Implement dedup in playbook or use RIDIs. When to choose EDA over monitoring? Use EDA for automated response, alerting for human notification. What if EDA controller crashes? Event lost unless buffered in message queue like RabbitMQ. And a few frequently asked questions. What is event-driven Ansible? EDA automates responses to real-time events using rulebooks. What event sources are built in? Webhooks, Prometheus, Kafka, Azure Service Bus, Amazon's Simple Queue Service. How is EDA different from cron? EDA reacts instantly to events. Cron polls on a fixed schedule. Let's recap the key takeaways. EDA closes the loop between monitoring and remediation. Webhooks are the easiest event source to start with. Always scope actions to specific hosts. Deploy separate EDA workers per environment. Ready to go deeper? Up next, Ansible Azure automation, then building custom Ansible collections, then configuration drift and compliance, and Ansible for Kubernetes. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.